We're going to be starting section 1.6 today, which is covering function transformations. These are transformation rules that are extremely important for us to get a good foundation for now because they're going to keep coming up repeatedly throughout this course. Today we're going to focus mostly on the horizontal and vertical translations, okay? And then we'll save the other types of transformations for other videos, all right? In general, a transformation is just a rule that has an effect on the graph of an original function. So all of these transformations that we learn in this particular section, they can be applied to any of the functions from our library, whether it be a square function, a square root function, absolute value function, etc. Okay, so let's look at the situation where my original function is considered f of x. So f of x can be any of the parent functions from my library, and I want to know what's going to happen to that graph if I add k to it, f of x plus k, where k can be any number, okay? So let's open this Desmos illustration, and I'm going to change a couple settings here. All right, so the first thing you're going to notice is you have the square root function, the parent square root function shown here in blue. And this is representing f of x equals the square root of x. If I take the blue away, I only have black, which is representing the equation in box 1, that parent function, okay? Now, when I bring blue back into play, notice it's the exact same graph as the black graph. That's because right now I have the value of k set at 0. So notice how blue changes, how the blue curve changes as I adjust the value of k. If I make k 1, the graph moves up 1 unit. If I make k 2, the graph moves up 2 units, and so forth. So this is considered a vertical translation or a vertical shift, all right? Now, if I were to make k negative, I would actually be subtracting the value from f of x, and that's going to move us downward. Okay, so vertical translation in the negative direction. All right, so let's formalize this in our notes. In general, if f of x is being added with k, when k is positive, we see that the graph is translated up k units. And if k is negative, we would actually be subtracting the value, so we would be translated down k units. Now, it's important to understand which coordinates from the parent function are being affected by each of the types of transformations we're working with. So in the case of a vertical translation, when you're moving up or down, you're only having an effect on the y coordinates from your parent function. They're being added or subtracted by this value of k. The x coordinates are not affected at all in a vertical translation. Okay? All right, so here we have an example of our own. I have graphed the function f of x, which it includes 5 critical points from the square function in our library, f of x equals x squared, okay? And I want to know what's going to happen to that graph if I were to subtract 5 from the function, if I were to find f of x minus 5. Well, the fact that you're subtracting outside of the function means you're translating the graph down 5 units, right? And that would mean your y coordinates are all being subtracted by 5. So notice I have the 5 critical points from the original function already listed. The point negative 2, 4, it's going to move to the point of negative 2, negative 1. I just found that by subtracting the original y coordinate of 4 by 5 to give me negative 1. So it's going to take me right here. Negative 1, 1 will become negative 1, negative 4. 0, 0 will become 0, negative 5. 1, 1 will become 1, negative 4. 2, 4 will become 2, negative 1. All right, so here is our new graph for f of x subtracted by 5. Once again, I want you to notice that it's the y coordinates from the original function that changed in value, but the x coordinates on both the original graph and the newly translated graph are the same. Okay. All right, moving forward. Now we want to know what happens if I add or subtract a number from x within my function. Now, when I say within the function, that means the number is being added or subtracted from x before you perform the main operation from whatever the parent function is. So in the case of, let's say, the square function, the main operation would be squaring. So here we would be adding or subtracting a value to x before we square it. Okay, so let's go back to the Desmos illustration here. And now I'm going to highlight box 4. Now notice the notation in box 4. It's showing the graph for f of x minus h. And right now I have h set at 0, so the graph looks identical to the parent function f of x. Okay. All right, now if I make h positive, positive 1, positive 2, positive 3, positive 4, and so forth, notice h is being horizontally translated to the right. Okay. Now you have to be careful here because while h is positive, in this case I've got it set at positive 4 right now, in your formula for the function, it won't appear to be positive. It'll actually look negative. In this case, it would be f of x minus 4. Okay, so you got to be careful because it looks the opposite of what effect is actually taking place. Okay, now let's say I make h negative. Now it's going to move you in the negative direction, right, to the left. Okay, and once again, even though h is negative, within your formula, it's actually going to look positive. In this case, I have h at negative 6, but in the formula, it would actually look like f of x plus 6. So that's something to watch out for, okay? All right, so in the case of f of x minus h, where the minus h is occurring within the function, when h is positive, we are going to be translated right h units. And when h is negative, we're going to be translated left h units. Okay? And it's important to understand that when you're translating left or right, that's having an effect on the x coordinates from your parent function. They're being added or subtracted by h. However, the y coordinates remain the same. All right, so notice in our next example, I'm using the same parent function as I did on the previous screen. Okay, I've got the same 5 critical points for f of x, and I just want to know what's going to happen to this graph if I make it into f of x subtracted by 2. Again, be careful here. This appears the opposite of what it actually is. While it appears you're subtracting 2 from x in the notation here, h is actually positive 2 here, which is going to move you to the right. You're going to be translated right 2 units. And that would mean you're adding 2 to each of your x coordinates. Okay, so the point of negative 2, 4 is going to turn into 0, 4. Negative 1, 1 will become 1, 1. 0, 0 will become 2, 0. 1, 1 will become 3, 1. And 2, 4 will become 4, 4. So here's our new graph for f of x minus 2. Once again, notice that both graphs, the original function and the translated function, their points have the same y coordinates. It's just the x coordinates that have been shifted. Okay. All right, now we go to practice 1. It's your turn to see how well you're understanding this. So for each of the following below, we want to describe the type of transformation that's taking place on f of x. Okay. Now by that I just mean, is it a horizontal translation or a vertical translation? And is it being moved left, right, up, or down? Okay. And then what operations will occur on the coordinates of each point from the parent function? So that means, are the x coordinates being added or subtracted by a value, or the y coordinates being added or subtracted by a value? Okay. So I want you to pause the video at this point, think through these and write some things down based on the notation for each function, and then come back to the video, check your work with mine. So in the case of f of x plus 4, notice the plus 4 is being added outside of the function. So this would have an effect on our y coordinates, and this would be a vertical translation up 4 units. There's no effect on the x coordinates in a vertical translation. The y coordinates from your parent function would all be added by 4, or add with 4. Okay. All right, for the next one, f of x plus 3, notice the plus 3 is being accounted for with x inside the function. Okay, so this is going to have a horizontal effect, and remember, it's the opposite of what it appears. So this will be a horizontal translation left in the negative direction, 3 units. In a horizontal situation, it's your x coordinates that are being affected. If we're going in the negative direction, we're going to subtract our x coordinates by 4, or I'm sorry, by 3. But the y coordinates will remain unaffected. Okay.